This is the Parent, Teacher, and Community Member Workshop number 5, Using Math to Help Others, Kokua Kekahi Kikahi, Problem-Based Learning Enrichment Activity. In this presentation, we will start with an overview of the presentation. We will then do a community building activity. Next, we will have an introduction to problem-based learning. Next, we will discuss planning and implementing problem-based learning. Then we will do an application activity, PBL in action. We will conclude this presentation with a wrap-up. Overview. Welcome to the 5th session in our Parent Workshop series. This session will focus on teaching math by solving real-world problems. The outcomes for this presentation are to 1. Know the basic concepts of problem-based learning. 2. Understand how a problem-based learning approach can be applied to learning math in and outside of the classroom. 3. Recognize the importance of connecting math to real-world contexts and using math to solve real-world problems. 4. Apply the PBL approach to solve a real-world problem. In this part of the presentation, we will do a community building activity. Community building, building a tower. Participants will work together to construct towers in teams. Let's get to know each other by building towers. Instructions. You will work in groups of 3. You will have 10 minutes to build the tallest freestanding tower using only the materials provided. All of the team members must help to build the tower. When time is up, the tower must be standing on its own. You cannot be holding it, and the tower cannot be taped down to anything. When the timer beeps, all participants must stop building and put their hands in the air to show that they have stopped working. The facilitator will measure each tower and record the measurements in a table on the whiteboard to determine which team has the tallest tower. Group discussion. How easy or difficult was this activity? What was the hardest thing about building the tower? What kind of strategies did you use to build? What did you learn about communicating with others? Did you have to use math at all? If so, how? In this part of the presentation, we will have an introduction to problem-based learning. Questions to consider. What is a problem? How do you define problem? How do you typically solve a problem? Think about if you see patterns in how you solve problems. What are some specific lessons you have learned through solving problems? Take a few minutes to think about these questions and write down your answers. Use the questions to consider what is a problem worksheet to help you organize your thoughts. If you are in a face-to-face workshop, turn to talk to a neighbor about your answers. If you are doing the online workshop, add your answers to the discussion board. Then respond to responses from at least 2 other people. Key ideas about problem solving. Solving problems is a basic and everyday occurrence. We all have developed ways and strategies to solve problems. We learn from solving problems. What is problem-based learning? Problem-based learning, or PBL, is a teaching method in which complex real-world problems are used as the vehicle to promote student learning of concepts and principles as opposed to direct presentation of facts and concepts. What is problem-based learning videos? View the videos at the provided links to learn more about problem-based learning. Characteristics. Characteristics of problem-based learning are student-centered, self-directed, hands-on, even real experience, culture and context-based, collaboration and group work, process-focused. Questions to consider. PBL and math. What are some specific examples of real-world problems in your community that can be solved using math? What about in the country, in the world? How can solving real-world and real-life problems using math help students to learn math better? How can community involvement, specifically helping others in the community, help students learn math better? Take a few minutes to think about these questions and write down your answers. Use the Questions to Consider PBL and Math worksheet to help organize your thoughts. If you are in a face-to-face workshop, turn to talk to a neighbor about your answers. If you are doing the online workshop, add your answers to the discussion board. Then respond to responses from at least 2 other people. In this part of the presentation, we will discuss planning and implementing problem-based learning. Problem-based learning in a math class video. Let's see an example of a PBL lesson. Fill out the Venn diagram to organize your thoughts about the differences and/or similarities between a traditional classroom versus a problem-based learning classroom as you watch the video. If you are doing the online workshop, add your discussion to the discussion board and respond to at least 2 other posts. As you watch the video, notice the differences and similarities in the classroom setup, teacher-student roles, source of math work or math problem, learning objectives, student motivation, and the problem-solving process. Group discussion. Let's share our thoughts about the differences and/or similarities between a traditional classroom versus a PBL classroom. Questions to consider for planning problem-based learning lessons. What is the PBL session learning objective? The objective provides overall direction to PBL session design. What is the problem? The problem provides the key units for structuring relevant learning experience. What are the resources available to students? Students are encouraged to use variety of resources for self-learning. What are the students' preferences? Teachers plan learning objectives, but student input is necessary to plan the process. What is the expected behavior? Students could be engaged in different learning behavior such as exploring, elaborating, and evaluating that mirrors real-world problem solving. How will the active learning experience be planned? Students can be engaged in different interactive class or field activities. How will students make a connection with real-world experience? Real-world examples establish authenticity and lead to higher concepts. How will students be motivated? Design problems and activities around student interests, cultural background, and life experience to motivate students to actively participate in knowledge discovery and problem solving. How will a self-directed learning environment be created and maintained? Developing effective learning behavior requires an environment in which students feel safe in exploring different avenues. Step by step. Problem-based learning uses a specified step-by-step method to guide the students through the problem-solving process. The following slides include the 8 steps for Project BEAM Kapilina Noel. Step 1. Select an issue, macro level. Guiding question. What is an issue that you are interested in solving? Step 2. Study the issue to identify some problems that impact you and your community, micro level. Guiding questions. How does the issue impact you and/or your community? Why is the issue important to you and your community? Step 3. Select and present a problem to solve using mathematical procedures and thinking. Guiding questions. Which problem are you able to tackle during the project period? Is the problem solvable by applying mathematics? How do you present the significance of the problem in a mathematical way? Step 4. Investigate the problem and develop a data or information collection and analysis plan. Guiding questions. What is known and unknown about the selected problem? How might you group known and unknown variables? Based on the investigation of the problem, what variables might affect the problem? Among the potential variables, what variables might be worthwhile to study further? What data and information do you need to find or collect on the problem and contributing variables? Where can you find or collect the data and information? How will you collect, organize, and analyze your data and information? Step 5. Collect and analyze data and information and find solutions by applying mathematical procedure and thinking. Guiding questions. What data and information did you collect on the problem and contributing variables? Based on the data and information collected, what are the possible solutions of the problem? How did you get to the solutions? Is there a causal relationship between the problem and variables, cause and effect? Can you formulate an equation to show the relationship? Step 6. Evaluate the solutions. Guiding questions. Among the possible solutions, what is the best solution? How can you verify that it's the best solution? Step 7. Reflect upon your learning. Guiding questions. What did you learn from this activity? What did you learn from your peers and group discussions? And finally, step 8. Consider the potential use. Guiding questions. What parts of the solution can be used to solve similar problems? How can others use the solution in the future? Student project example. Here is a student project example created for the Project Beam Capilina no Eo. Review the website to see the 8 steps of the problem-solving process in action. In this part of the presentation, we will do an application activity, problem-based learning in action. Application, PBL in action. Work in groups to solve real-world problems using math. Now it's your turn to apply what you've learned about PBL and the Project Beam Capilina no Eo problem-solving process. PBL in action. You will work in small groups or pairs. You will choose a problem to solve out of the problems you listed earlier in the workshop. Go through steps 1 through 4 of the Beam Capilina no Eo problem-solving process. Hypothesize as much as possible results and answers for steps 5 through 8 of the problem-solving process. Present your problem and discussion with a group. For this activity, you will have time to discuss and research your problems to complete steps 1 through 4 of the problem-solving process. While you will probably not have time to complete the entire process, it might be useful to think about how steps 5 through 8 of the problem-solving process would play out if you did complete the project. Use the 8 problem-solving steps worksheet to help organize your thoughts. If you are doing the online workshop, add your answers to the discussion board. Then respond to responses from at least 2 other people. This presentation will conclude with a wrap-up. More questions to consider. How can PBL concepts help your child with solving problems? How does your child typically react to a problem? Do you notice any specific ways in which your child goes about solving problems? Can you think of any specific lessons your child has learned through solving problems? How do you usually help your child face problems or new challenges? After this workshop, do you think you will have a different approach to helping your child solve problems? If so, how? If not, why? Now that we have learned about learning through taking specific problem-solving steps, take a few minutes to think about these questions and write down your answers. Use the questions to consider a problem for my child worksheet to help organize your thoughts. Optional. If you are in a face-to-face workshop, turn to talk to a neighbor about your answers. Optional. If you are doing the online workshop, add your answers to the discussion board. Then respond to responses from at least 2 other people. Note: please be mindful that parents may not feel it appropriate or may not feel comfortable sharing about their children's experiences. Tips for successful PBL. Prior knowledge. The amount of prior knowledge and activation of the prior knowledge in the discussion is a very important determinant of the achievement and increasing the interest among students. Quality of the problem. The well-constructed and relevant problem will motivate students, trigger and stimulate discussions, and increase the time spent in self-study. Facilitation behavior. Teachers, as facilitators, can maintain communication, collaboration, and critical thinking among the students. Student-centeredness. Motivation of the students is increased when they are asked to lead the learning process. Putting students in charge will lead to application of the self-determination for learning. Teamwork. Team dynamic will ensure that everyone is participating efficiently and effectively. Communication and cooperation. Communication and cooperation are both inherent and essential concepts of well-developed PBL, leading to improvements in teamwork. Well-functioning communication protocols among students can be useful and often lead to efficient collaboration in all steps of PBL process. Organization. Organizational skills are other key components students need to learn and acquire via PBL. Teachers can support this skill set by defining structures for group work and suggesting systematic processes towards solving the problem. Ground rules. Ground rules are also often very important in maintaining the organization of the group work and maintain team dynamic. Rules such as keeping time, active participation can be defined by students themselves and should be respected by every member. Post-survey. This is our last workshop. Please remember to take the workshop post-survey.